streaming is a good paradigm, I would say, to implement a lot of applications. It's kind of a natural match for applications that you've implemented following an event sourcing architecture, CQRS architecture, or I mean, most applications are currently being rewritten in a reactive or event-driven fashion. That is half the way to actually turning them into a way that you can run them as a streaming application. So I would say the vast majority of applications that you're writing as reactive applications are actually good matches to consider for streaming architecture. What you definitely need to do is think about how do you organize and maintain state, right? You're going away from having a centralized database, a shared database between different processors. You're going to state that is owned by a specific piece of computation, right? So whenever you want to interact with multiple states, you kind of have to redesign this pattern a little bit, right? You interact with that state and then you see, okay, I also have to interact with that, so you're actually sending a message or a piece of computation over there. So kind of doing that model and trying to capture it in the streaming data flow graph, like making this transformation in your head is, I think, the hard part. Once you've made that, you'll actually see that a lot of other things become easier. The part of actually managing the state and like reasoning about performance and so on. Flink has a few primitives that it's built on, each of which actually have a kind of background where they came from. So the first one, it's a system that's really streaming underneath, even though, like, if you look at the Flink project initially, it was doing actually batch processing, but it built batch processing on a streaming data stack. That decision was deliberately done in Flink's predecessor project still. Flink is a successor to an academic research project. And in that project, we made the decision, okay, let's try to build the data stack in a streaming fashion. It's kind of been influenced by how many distributed databases or other databases worked. For example, Impala made a similar decision back then. And this turned just out to be a good decision and to open the way to implement it as a stream processor. Building a powerful event processing paradigm on a streaming data stack is easier than on a batch data stack. That was the first thing. The second thing was introducing the concept of failover via snapshots and recovery, and that was just looking at various algorithms in literature for distributed systems. How do you recover state? In particular, we came across the Chandy-Lamport algorithm, and Flink snapshot method is a variant of that. That is how snapshots came into being. Time. The way Flink treats time is very much inspired by what was then called Google Cloud Data Flow. It's a model that was developed by Google that they built their cloud data flow system on, and there was later the foundation of the open source project Apache Beam. So this is how Flink's concept of time came into being. We're working on quite a few things in Flink. I mean, one thing is clearly that the power of flexible state and snapshots and scaling this very large, making this very efficiently elastic, highly available, with very little effort. This is a line of work where we're putting in a lot. Deployment models interplay with newer kind of deployment ecosystems, Kubernetes in particular, like overlay networks and so on, pose currently a bit of a challenge with the whole network configuration. And then there's a lot of management work around state administration, if you wish it, right? If you actually start using Flink to own the ground truth of state of applications, you do seriously want some tools around that, the ability to export it, the ability to schema upgrade or schema migrate it, and so on. It's kind of very, very similar, like the tools that databases need to administer large amounts of state. So we're going to see a bunch of these things. On the other hand, what we're also going to see is that even though Flink is a batch and streaming system together, it has a unified batch and streaming API, the data stream API. It still has different implementation of operators when you run batch and streaming. So this is something that we want to combine so that, for example, in the streaming world, you can make use of more efficient implementations when you're not at the real-time peak, but let's say you're in a reprocessing or in a catch-up phase, right? Then you want to trade you want to trade the fact that you can give real-time insights into what's the current state for faster catch-up, for example. Because at that point in time, you're anyways not presenting any interesting real-time information. So you might as well decide to not be able to expose them and rather catch up faster. So things like that. There's a bunch of work. Yeah, the final thing, which is maybe the one that is easiest to grasp, is actually the Stream SQL layer. Stream SQL has started as a pretty big effort in Flink, like a cooperation between various groups and companies in the community. It's in this release publishing the first set, I would say, of really sophisticated usable features like differential aggregations and all of that stuff. So I mean, streaming SQL is kind of a model that works on computing on changes of the state on the input, and being able to exploit this for example, for aggregations for different forms of windows, grouping windows, sliding row windows, and all of that, like they're defined in the SQL OLAP syntax. That is a big thing. There's definitely going to come more feature coverage and more work on performance in that area as well. A first version has been released with very simple operations. You know, so SQL has a lot of operations, right? You gradually add the more complex ones. The very simple ones are released. A good bunch of the complex ones come in the upcoming release 1.3, and then there's going to be a long tail of of supported features that are coming after that. I enjoyed it a lot. To be honest, when I found out about it, and I looked at the set of speakers that you had, I thought like, wow, okay, this is an incredible set of speakers. I mean, not many conferences can boast such good speakers. And I'm not saying you got the vice president of that and that corporation who can talk about some very abstract stuff for the management or what I mean like really extremely good hands-on technical people that are talking about awesome stuff. Very, very hands-on, very concretely. That was a very nice selection of speakers. And when I saw that, I thought like, yeah, well, I want to be there as well. Yeah.